Hey, Ignite Science kids, chemistry kids. I want to make a quick video talking a little bit about radiation and how we measure radiation. And this is called a Geiger counter. See that red bulb popping off? That's a Geiger counter, and it is measuring the amount of radiation that is coming from different devices, okay, on there. And so this is, sometimes it'll make a clicking noise, clicking sound. This one doesn't really make sound as much as it makes a light. And you can actually count the number of times that it blips for the amount of radiation. So notice that the light is going off. There is just some regular background radiation that is pretty much everywhere around us, okay? Especially as I get closer to certain different types of devices and things like that. I can even measure my face, and we'll see if it actually blips or not. Oh, good. Well, everyone. All right. Radiation is normal, okay? Now, what's not normal is having a whole bunch of alpha, beta, gamma radiation being striked out of different things. And so I want to kind of show you one example. A lot of times people are always worried about cell phone. So take a look at a cell phone, radiation on cell phone. I'm just kidding. It's not really my cell phone that's doing that. I have some radioactive devices underneath of it. And you see that the radioactive devices are what's actually causing the radiation, okay? Cell phones do not irradiate like that, okay? And you hear it still beeping at me here, so I'm gonna put those away a little bit there. And so again, this is our Geiger counter, and you'll hopefully notice that cell phone behind it, yeah, it blips a little bit, but it's just the same as background radiation. So a lot of people think that cell phone cause cancers and things like that. That is not really the case or true, okay? All right, now, I do want to show you these guys, though, because they're pretty cool. Blip, 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 blip. Going crazy. Can you hear it? Probably shouldn't put that so close to my skin there. So we have different samples here. So the very first one we have is polonium here, okay? And polonium is going to undergo what we call an alpha decay. The emitter is right there. So not too crazy on that one. This one here, we have strontium. Strontium is going to undergo, I believe it's going to undergo a beta decay here. So much more active there. And this one here is cobalt. Note that the cobalt is going crazy. It is emitting a lot of radiation from there. Okay. Just to prove that it's not on my hand. Okay. It is inside of that device there. All right. So the Geiger counter, radiation. Again, radiation is normal. Background radiation. There is some. You're exposed to radiation every day. However, there is an appropriate amount of radiation to be exposed to, and you do not want to overgo or get exposed to too much radiation. And having something like a Geiger counter is where we can measure amount of radiation and make sure we're staying safe, okay? Especially in places that had, radiation or radioactive devices or radioactive material inside of them. So just a cool little demonstration. Again, background radiation, normal. Cell phones do not undergo alpha, beta, gamma decay, okay? Yes, they do have electromagnetic radiation energy, but not the nuclear alpha, beta, gamma, anything different than background radiation. So again, that's not, a lot of people think that they're going to cause cancers and things like that. There's really no scientific evidence for that. I could be wrong. Show me the evidence, change my mind. But as far as, that would be groundbreaking news if that was really true. We wouldn't be carrying cell phones in our pocket 24/7. So, so cool little Geiger counter there, activity. Just want to show you guys something cool today. All right. As always, if you need anything, feel free to email us.